Now, I've got a folder right here. It's completely empty. There's no content at all. Let's start out a Git repository. Now, we definitely could git clone something, and that would get us started. But instead, let's do this, git init. Now, when we said git init, it initialized a new empty Git repository here in this folder. Here's that empty.git folder. Let's open it up in VS Code and take a look at it. Now, I'm very specifically opening up the .git folder, not the containing folder, because VS Code will hide the .git folder from us. Now, there's quite a lot of stuff in here: head, description, config, refs, objects, info, hooks. We're going to look through all of them today. It's going to be really cool. Our goal, to understand what each of the files in the .git folder does. Okay, so first thing we need to do here in our empty Git folder, git status, git log. We have nothing in our repository. Let's solve that. Let's echo file1 to file1.txt, git add file1.txt, git commit -m, file1, breaking the quintessential tradition of naming the first commit initial commit. Please increase the font size here in the terminal or in VS Code. Great request. So yeah, thank you. Inside VS Code, good call. Okay, so yeah, it'll be a little bit difficult to see the sides, but once we open up each one, then we'll be able to see a lot more content over here. I don't know how to increase the font size here on the left. On Mac, you can scroll wheel to zoom in. On Windows, I'm not sure how to increase the font size. So sounds like I have some homework to do. Thanks for that suggestion, Somya. Okay, we created a commit. Now let's go look through this .git folder. Now we have a refs folder inside objects. We have an objects folder, and inside objects, we have various folders. And inside each of those folders, let's open one. And do I want to open it anyway? Yes, here's a big binary blob of mess. So what is this? Well, it is a zlib compressed file, and it identifies all of the content for these objects. Let's do a git log, and we can see this is commit 97602BA. So if we come over here, 97602BA, the folder is the first two digits of the Git hash, and then the files inside are the rest of the Git hash. But wait, we only did one commit. Why do we have three things in our objects folder? Control plus. Ooh, let's try it. Control plus. Oh, nice. I am forever in your debt. That is so awesome. Thank you. Okay, so let's dig into one of these. Now, how do we uncompress it? Well, Googling a bit, how do we uncompress a Git commit? Well, we can cat that thing, pipe it to gunzip. We can do some other things. Here's a C program that will unzip it. I wrote a Node program here called unzipper that is just, let me pull up unzipper. Here is unzipper. It's a fast Node program that will start to uncompress the content. So let me zoom in one more time. Grab the zlib library, grab fs, and then just read the file, unzip it, and we'll do the thing. So let's do that. I am going to unzipper.git/97/ Objects 97. Let's unzip that thing. Okay, so here's the contents of that thing. We've got commit 178, this tree, author, here's my name, email, and commit date and time. And here's the content. Ooh, this one says 0B9F29. Let's, I recall seeing one of those, 0B9F29. Let's unzip that one. Okay, unzipper, 0B9. Here's the contents of this file. Now, it's a little bit mangled because it's encoded in a weird way, but we can see it is a tree node, 37 bytes for this entire file, and we've got some content here. Well, we can use git options as well. Let's say git, where is it? There it is. Git cat file -t 0B9F. And we see that it is of type tree. We can do the same thing with 9760, and we'll see this is of type commit. Now, git cat file -t will give us the type. Let's go after the content. We can do that not with -t, but with -p. And so it will cat all of the content. We can see that that's exactly the same. The only difference is it has the type and the size up here at the top, but there's all of the content. This is a tree node, and this is a commit node, and we can see that the contents of it references this tree node. Okay, let's get cat file -p that tree node. Here's the tree node, and it has references to the various blog or the various files. In this case, we only have one. And here's a reference to this, git cat file -t. There, we see that this is a blob node, git cat file -p. And here's the contents of the blob, that actual file. Why first for alphabet? Good question. I only need to get to something unique. And so I could say git cat file this entire commit node, but well, that's a lot of typing. All else being equal, as soon as we get to unique, we're fine. Oftentimes when you're looking at a git log will give you the full thing, but then we'll say git log --1 line, and --1 line will shorten it to the first 7 characters. Now that's often unique enough that we can use that in place of the full git hash. Good question though. Thanks for calling me out there. So navigating through these and catting them each and taking a look at each one, that was kind of a pain. Let's create another file, echo file2, redirect to file2.txt. Do we still just have those 3 objects? Let's refresh. Yep, we just have those 3. Git add file2. Let's add it to the staging area. Now let's refresh. Ooh, we have a new one. Adding a file to the staging area will create this new node inside the objects folder. So let's git cat file -t. What was that blob? That blob was 6C49, 6C49. There we go. It is of type blob. Let's go look at the contents of that blob. And there's the file too. Now, it's only in the staging area right now. So let's commit that. Git commit -m. I'll just name this commit file2 just so that we can keep track of it. And now we have a new commit right here, git cat file -t. That one, it is of type commit, git cat file -p. And we can see the tree node associated with that. Here's the parent commit. It would be cool if we could, well, kind of navigate all of these a lot similar. It's similar to referencing containers. Yes, we have big, long hashes. So let's fire up a mechanism where we can probably browse these things a little bit easier. Now, here's where our sample application comes in place. This is Git Explorer, and let me set the path, the URL to that here in chat. And so you can see that now we've got this mechanism for being able to view this tree. Now we do need to create an env.json file that'll specify the path to our folder. So let me fire up Git Explorer here. And here in my source folder, I've got that file, and it points to that Git Explorer demo Git folder. And so now that we've got that in place, I will npm start that app. It's going to do the TypeScript build and run. And so let's hit up localhost 3000 and take a look at the content. Okay, so we have these 6 nodes. That's kind of cool. Here's the 6 nodes. If we click on one, it will show us the content. So there's that one. It looks like it's a tree node. Here's this one. Oh, that's a blob node. It would be cool if we could say, show the types. So let's color them. Red is commit, blue is tree, green is blob. So here's a commit, a blob, a tree. Nope, these are blobs. These are trees. That's kind of cool. Let's put them in alphabetical order so that we can see them. Let's show the git commits. And now we can kind of wander through them a whole lot more easily. Okay, so I've got this commit. Here's this commit, and it DA89, and it references B75F. So let's go to B75F, and it references the 2 files that were part of this commit. So E21 is the first file. Here's that E21, and here's the contents of the file. For n files, do we see n objects? Let's take a look. I'm going to flip over to parent-child so we see references. Let's draw lines between them. Let's add the tags. And so each blob is going to be 1 file. And then each tree will reference all of the files in the current directory. So here on this tree node, as part of this second commit, we see that it references 2 files. And each of those files is 1 blob. So for each blob, we will get 1 file. For each file, we'll have 1 blob. But then we may reference tree nodes that will start to collect them in interesting ways. And a commit may reference multiple tree nodes. So let's commit another one. I'll come in here and I'll say echo file3 to file3.txt, git add file3, git commit -m file3. Now I've got 9 nodes here. Let's refresh. Show the types, parent-child, show the tags, show the lines. Okay, here's our latest commit. This commit has a parent commit of this commit. This commit has a tree node here of this commit. Here in this tree, we reference 3 files. Each of those files then is a separate blob. So here's file 3. Now, it references file 2. File 2 was committed here. It's referenced by this tree node as well. And then also, this one references file 1, which hasn't changed at all. It's still right here. So that's really cool. We can explore these objects here in our .git folder. Well, what happens if we create a folder? I'm going to say make dir folder. And now I have those 3 files and a folder. And I'll say echo file1 to folder/file1.txt. Now file1 out here and file1 inside that folder now have identical contents. Maybe that's an accident, or maybe I did that on purpose. Git add folder/file1, git commit -m folder, git log --1 line --graph. dash dash decorate dash dash all, and decorate dash dash all. Okay, so now we see our content, and we've now got a folder. Let's refresh our graph and take a look at how that works. Show the type, parent child, show the lines, show the tags. Here's our new commit. Now this commit references one tree node, but this tree node, notice it has a reference to another tree node, this tree node. Now it says, I've got a tree node and I've got that folder. Okay, so in this tree node, it says, I've got one file in it. That's ideal. We have here in our folder, we have the 3 files, and we have one file inside that folder. Each folder will get a tree node. Each file within that folder will get a reference to a blob. So this references not only the 3 files out here, but the one file in the folder. Now, what's interesting, we only have 3 blobs. 1, 2, 3. Because the contents of file 1 is exactly the same, we don't need to save that again. We already have that in our repository. I think only the commit finalizes the changes to be reorganized. Yes. Ooh, is any of this updated after add but before commit? Yes, we create these blobs as we add it. As we commit it, we create the tree nodes and the commit. For each new add tree node is created. For each new add, only the blobs are created. The tree nodes are created as part of the commit. Can you try changing the contents of folder/file1.txt? Good call, let's do it. So folder file1.txt, let's add some changes. Some changes here. And then we'll come back here, git add folder/file1.txt. Wait a minute, wasn't it already part of our repository? Why did we have to add it? Well, what we're adding is all of the changes. We're adding the changes to the staging area. So I can see how that verbiage is confusing, but yeah, there we go. So we've added it, we have not committed it yet. Let's refresh our repository and take a look at what's here. Show type, parent child, show the tags, show the lines. Ooh, we have this new thing out here. Here's the blob associated with that change. Now we haven't committed it yet, so it's just a blob in our repository, but that's that mechanism of being able to add it to the staging area. But Git would also be tracking uncommitted changes, right? Git identifies which files are untracked, but it isn't tracking the contents of those files. Are the changes also stored as different blob? If not, how are the different changes tracked? Yes, this blob, the one that has file 1 and some changes, is different than this blob that just has file 1. So let's commit it. Git commit -m file 1 changed. Now let's come back in here, refresh, show type, parent child, lines, tags. Here's our new commit. Now our new commit references this tree node. This tree node notes that it has a folder. It can't reference this one because that one references this file. So we have a new tree node that references this new file. But we also have all of the old files out here in the regular directory, so it just references those original files. Are the changes also stored as different blob? If not, how are the changes tracked? Yes, we changed this file and we got a brand new blob. Well, what if I'm not done changing this? I want to say, and more stuff. Now I can git add folder/file1, and then I can say git commit --amend -m more changes. Oh, I spelled amend wrong. 1 M in amend. Now this amend will change the current commit. So if I do a git log dash dash one line dash dash graph dash dash decorate dash dash all, then I will see that I only have that new commit 5D2. I no longer have this old commit 454. Or do I? If we go look into the .git folder inside the objects folder, we can see that we have the 4.5 folder still. And inside the 4.5 folder, we still have that content. Did you accidentally commit the secrets, but then adjust your Git history to try and pull it back out? Yeah, sorry. The content is still in Git. Let's refresh our graph and show this. Refresh. Let's show the type, parent child, lines, tags. Now we have this commit, but then from this commit, we see that its parent is 7C, this one down here. This commit is a dangling commit. Nothing points to it, but it's still in our repository. Is it possible to see the lines for only one particular chosen tree to highlight the path of only the one we were trying to view? Ooh, I like that feature suggestion. Right now, that's not what this program does, but I suddenly want to add that feature. Great idea. For every commit, tree node gets created. For every commit where the tree is different, the tree will get created. So probably we're changing files, so it makes sense that we would add new tree nodes. But it isn't necessary if we're not adding files or changing files. What would a commit be if you're not changing files, though? Yeah. Git show dangling hash shows actual content. Yes, here's that dangling commit, and it has the content still in it. So here's that change that was in the middle. Here's that final commit. What is a dangling commit? It's this one where we have no branches pointed to it. So let's pivot from looking at the objects folder to looking at the refs folder and start talking about tags and branches. Now we have this head pointing at main, and that was really interesting. Let's take a look at that. If we come in here to our folder, let's close the objects folder, we have a head right here. And if we open up head, it says refs heads main. We do have a refs folder right here. Let's open up refs. Ooh, there's a heads folder inside. Let's open up heads main. 5D2F8C. That looks familiar. Here's that commit, 5D2F8C. The refs heads main branch is pointing at this particular commit. And then head is pointing at refs heads main. Well, I can create a new branch. Let's say git checkout -b new branch. Now, if I do a git log --one line --graph --decorate, I will see that here's new branch, and now head is pointing to new branch. Let's pop open the head file again, and it's now pointing at refs heads new branch. Open up refs heads, and here's new branch 5D28C. Now, to your question about what is a dangling commit, let me say git checkout DA89. Should I try again? No. Git log --one line --graph decorate. Oh, let's look at this first. You're in a detached head state. Wait a minute. So I took my head off? This is a really, really scary message. And it's interesting, but it doesn't need to be that scary. What is a detached head state? Well, as we looked at this head previously, head pointed at a branch here inside the refs folder. Now it points at a commit itself. So if we were to commit some stuff, let's say echo file7 to file7.txt, git add file7, git commit -m file7. Now let's go look at that history. And head is now pointing at this new commit 79D. Let's refresh our graph and take a look at this. Show type, parent child, show lines, show tags. So here is that 79D. Now, head is pointing at it, but nothing else. So, well, what if we then say git, oh, actually, let's look at this for a minute. Head, I've got my checkout folder, and I have file 1 and file 2. Where's file 3? Did I just lose work? Ah! Now I'm in a detached head state. Well, we've checked out the folder at this particular commit. And in this commit in the history right here, these commits didn't exist. So we don't have these additional files. But all of the content is still in our repository. It's just not in our current working directory. Okay, so let's come back to this detached head state. If I were to say git checkout -b branch, now when I do a git log, I see that head is pointing to a branch. I am no longer in a detached head state. I am now pointing head at a particular commit. Phew. What is a detached head state? It just means my head is pointing at a commit instead of a branch. If we were to remove that branch and check out a different place, it would be difficult to get back here. So let's do that. I want to say git checkout main, git log --one line --graph wait, where's branch? Well, right now I'm only visualizing the content from the current branch down. So if I want to, I need to say --decorate --all. --all will show me not only my current branch, but the other branches as well. Okay, now I want to merge branch into main. So let me say git checkout branch, then git merge main. And now if I do a git log --one line --graph --decorate --all, I have that merge where these two things are put together. Now really I wanted to put main up here. Well, main right now, main points at this commit, and I want main to point at this commit. Well, I could go like this and just make main point where I want it to be. I just moved main. Don't do that. Because let's put main back where it should go, and let's do this correctly. Okay, git checkout main, and now git log --one line --graph. Instead of merge, I said git branch -d branch. Git log --one line --graph oh no! Now have I lost work? No, but I don't have a way to easily get to it. If we come back into our visualization, none of the nodes have changed. We still have all of our content, show type, parent child, lines, tags. But we need to be able to get back to this 79D commit, or even this one, F57 commit. So let's look at a new file here inside the refs, inside the .git folder, the logs. Now in here, we have logs for main and logs for new branch, logs for head. Here's the logs. Here's where it was and then where it went to. And here's the details about that. And we can kind of cruise down this list and see where head was. Well, it was at F57 FC, and it moved to 52 FC673. So let me check out this one. Git checkout this one, and now I'm back into a detached head state. Now, we don't need to be scared by this. Git checkout dash B branch, git log dash dash one line dash dash graph dash dash decorate dash dash all, and we're back. We're no longer in a detached head state. Now, what if we wanted to view this log using git commands? Git ref log. Now, git ref log is a great way to be able to browse through the log references. I've actually heard it pronounced reflog, and I'm like, yeah, that's interesting. But the ref log is a great way to navigate through branches and to get back to where you were when you don't know where you were. Yes, detached head state means it doesn't point to any branch. Good call. So let's talk about tags. Git tag 2020, nope, 2021. Git log dash dash one line. We now have this tag. Let's go look through our Git repository, and we'll see here in the refs folder, we have a tags folder, and here's 2021. It just points at this commit. Tags and branches are pretty much the same. Let's also now talk about remotes. Well, I want to be able to push this content to a server. Git push origin main. Wait, I haven't hooked it up to any remotes yet. So I could go up to GitHub or Bitbucket and create an account. Maybe I create an account on GitLab, but instead I want to create a new server. So here's this Git folder that we've been working in. Here's a server folder. It's blank. So let's come into this server folder, and let's say git init, but instead of initializing just a regular repository, we'll say dash dash bear. Now, when we say bear, it's only the contents of the .git folder. It doesn't have a working directory. Now that makes a really good server. Here's that path to the server. Okay, back in our regular system, we'll say git remote add origin. Why origin? We can call it that, or we can call it server or foo or your PC. I'll just call it origin. And then I'll give it that path. Now the path could be a URL. It could be a UNC path. It could be a relative path. In this case, I'll just give it the path to that folder. Now I have a remote. Git remote -v. Here's the remote that I have. Now I want to push to it. Git push origin main. Now I push the main branch to origin. So why do I specify origin first? Well, I can say git push origin, the main branch and the branch and the 2021 tag. I can push all of these things into the origin server. Okay, so now that we have that origin server, we can come back to the server and we can say git log dash dash one line dash dash graph dash dash decorate dash dash all, and be able to see all of the content. We pushed all of those commits up to the server. Now we still have no working directory. So, head points to main, but that doesn't really mean anything. But now here, when we do a git log dash dash one line dash dash graph dash, we have all of these red ones as well. Let's pop open our .git folder, and we have a new folder called remotes. Inside remotes, we have a folder called origin for that folder where we named our origin. And here's main. Here's where I think the server was. Here's where I think the server was there. So these are just files pointing at commit hashes. The branches, tags, remotes, remote tracking branches are just labels, name tags on particular commits. And so if I want to move those name tags around, I definitely can. So let's do a ninja move here. I want to move the main branch right here. Git update refs heads main to point to head. Now this is one of those do not pass go, do not collect $200, don't validate that I'm merging correctly. I just picked up that branch and I moved it over there. Let's go look at that history again. And we see that we moved the main branch from here to here. Cool. Now probably what we want to do, let's do it correctly with new branch. Git checkout new branch, git merge main, git checkout branch. So we did that one correctly. Git log dash dash one line dash dash graph dash dash decorate dash dash all. And now we see all of those branches are lined up. So branches are just files in that refs folder. We can use reflog to be able to browse through it. So let's look at some other logs here. Now we have all of the logs of where the refs have been. We also have logs like orig head. Now, actually, that's not a log file. Oh, we already did that. We looked at the logs here in the logs folder. Next, let's look at hooks. Hooks are really interesting. Let me open up one of these hooks. Apply patch dash message. And so you notice that it's a shell script. Now I am running on Windows, but Git has enough Linux in it to be able to run these shell scripts. Here's a commit message, and it's also a shell script. Post, apply patch. Now one of these is actually a Perl program. Not that one. Of course, I walked right past it. There we go. So here's a Perl program, and this runs when we do this task. Now, all of these are .sample, which means they're disabled. So let's go rename all of them and put in some simple stuff. I'm just going to come dig into this sample folder and go copy all of these into place. Here inside the hooks folder. And now I've just created one that doesn't have the .sample on it, which will just output all of the arguments passed to it. Now, hooks are a great way to be able to automate tasks. So let's do some tasks and see what it'll do. Git, actually, echo file4 to file4.txt. We just created a file. Git wasn't involved, so no hooks there. Git add file4. Nope, no hooks there. Git commit -m file4. Ooh, we got some hooks. A pre-commit hook, a prepare commit message hook, a commit message hook. In each of these places, we could do interesting things like lint that file, run unit tests, validate that our commit message is in the format that we expect. We can do lots of automated tasks here, things that we wouldn't necessarily want to do manually, but we can do them automatically as Git hooks. So that was a bunch of hooks associated with committing. Now I can say git push origin branch. And now I have some more hooks. Here's a pre-push hook. And I can do all kinds of interesting things. Hooks are a really, really good way to automate tasks. Now, they're a great way to automate tasks, but how do I share my scripts with you? Can I say git add.git/hooks/ prepare commit, pre-apply patch, git status? No, I can't commit content inside the .git folder. So to be able to share these scripts, we'll need another way. Now, if I come in here to this git hooks npm package, now this is a great way to be able to do this. Once I install this git hooks package, it will go alias all of those commit hooks to files outside of the .git folder. It actually creates a .git hooks folder and names all of those scripts there. And then inside my .git/hooks folder, it will create symlinks off to these files. Now that's really cool. As I install this git hooks package, maybe I'm using Node for something else, like my client-side libraries, or maybe I have a Node server, or maybe I just need this extra automation script. I add these this git hooks package, and now I can start to commit my automation scripts. Now you can use them too. That's really helpful. Next up, let's take a look at configuration. Now, right now in here, I have a config file. Now, this is an INI file that will specify the details associated with this repository. Now, this is interesting, but this file only overrides the things from my local directory. So let me go open that file, open file, C users rob.git config. Now here's the .git config file, and this local one overrides this system one in my user profile. Now this one might have additional details. I have some aliases. I have my diff tool set up, my merge tool, and I also have my user name and email. Do you remember when you first set up Git and it said you need to set your user .name and your user.email? That's what it was doing, is it was setting these user.name and user.email settings. Now this file actually overrides the system details that is in the program files directory where I installed Git. So let's go to C program files x86 Git. Nope, it's not an x86. Git. And then I always have to go find it here. CMD, nope. Bin, nope. Let's see. There it is, git config. So this is the configuration settings associated with my machine. As Git wants to find a config setting, it will look in this one, and then it will override it with all of the details that I have here, and it will override that with all the details that I have here. So you notice that in this file specific to my repository, it has the remote URL and the remote origin URL, which is really helpful. In this system one, then I have my username and email. Well, what if I'm doing a business project and I want to use a different email in my business project than in this, than in the rest of my system? Well, I can just copy these config details and I'll set this to robrich@company.com. Now, when I commit, I'm not creating commit specific to my personal account, but rather to my company account instead. Let's do that. Echo file5 to file5.txt, git commit, git add file5, git commit -m file5. And now, oh, there's all of our hooks. That's awesome. Let's come in here and refresh our visualization. Show type, parent child, show lines, show tags. Here's that latest commit. We can see here's robrich@company.com. And so that commit has my new email address, the one that I overrode specific to this repository. In my previous commits, I still have my old email address. That's fine. If I do that, if I set that configuration file right as I initialize my project, I know that I'll only use the correct email address in all of the places. Is GitHook NPM available for Windows? Yes, it is a node module and it works on all platforms. Great question. So now I've got this config file. There are some other config files like in here in info, there is an exclude file. Now this exclude file looks a lot like a .gitignore file. I could ignore things like bin, obj, star.user, .vs, node, modules, star.jar. Yeah, I could ignore all of those things here in this exclude directory or exclude file, but we know that we can't commit files inside of our .git folder. So let's not do that. Let's not modify our exclude file here, but rather let's create a new file out here in our Git folder that is an exclude file. Echo foo to .gitignore. And now let's open up that gitignore file and we can exclude the content that we need. There we go. Now that it's outside my .git folder, now I can see that it's a file I can commit. Git add.gitignore, and now I can make that happen. Can you show the location of the second git config file? Yes. Here's the config file in my .git folder. It's right here, this config file. Next up, we have this git config file that is in my user home directory. So in this case, C users rob.gitconfig. If you're on a Mac or Linux, it's in the tilde directory. And this is the third one, the system one, that is in program files git etc git config. Now, you probably don't want to modify this third one. I would probably suggest that you ignore that it even exists. But this second one is really helpful in my user home directory. C users rob.gitconfig. Great question. So we looked at the exclude file. Let's also look at this description file. Now, this description file is the name of the repository if we're using Git InstaWeb. Now, unfortunately, Git InstaWeb doesn't work on Windows very well, and probably running a web server as part of our Git repository is not something that we'll do very often. If we want a website, we'll probably use, well, GitHub for this. But it's interesting to know that that config file is here to be able to help with Git InstaWeb. Let's look at some other configuration files. Here is the index file. Now, this one is, well, binary. How do we read this index file? Well, we can come here to this GitHub, this Stack Overflow. What's in the Git index file? It walks us through the mechanism where, you know, this bit is this and this bit is this, and yeah. Here's a Python program that is able to read that Git config file and parse it and understand its details. But the other part of this answer that actually is really helpful is we can say git ls files -- stage. Let's do that. So git ls files -- stage will list the contents of this index. Now, this index lists all of the blobs for all of the files in our Git, in our working directory. Now, Git can use this to really quickly diff the files in our directory together with the objects in our repository and know if we have something that's changed. So when we say git status, it does that quick check, validates all of the SHAs on both sides, and says, yep, here's the one file that's different. That's that index file. Now, parsing it by hand is hard, but git ls files -- stage is really helpful. Ooh, since Git hooks are not pushed or pulled, how can we enable some hooks for clients, say to some given repo? That's where this Git hooks npm package comes into play, because it will symlink the hooks from our hooks directory into a different folder that we can commit. There are other packages in other languages that do a similar thing, symlinking those files into a place that we can commit. The beauty is once I npm install, as part of that installation process, it will rig up those symlinks. So the moment that you check out this repository and npm install, you'll have the symlinks in place too. Git rebase, cherry pick? Yes. Let's dig into those in a second, but first let's talk about temp files. Orig head. As we're passing details into our hooks, we need to be able to pass things like the commit edit message or where head was. So here's some temporary files. Now, they're kind of annoying. I don't want to, sometimes we'll have an info/refs file that is also a temporary file. You can, for the most part, ignore these temporary files. Now, the cool part is that each of these files are accomplish particular tasks. And I'll put this reference in chat as well. And let's take a look at what this is. This lists each of the files and exactly what it does. We talked through all of them today, but it's kind of nice to be able to go look at each one and see a particular instance. Okay, so that's all of the files in the .git folder. We got to see all of them. Now, this isn't all of the files inside of, or all of the commands inside of Git, but rather all of the files stored. But, let's dig into other commands like rebase and merge. What's the difference between git config -- global versus git config -- system? Good call. If I just say git config, I'm modifying this file right here. If I say git config -- system, then I'm doing, where is it? If I do system, I'm doing this one, the one associated with my profile. And if I do global, then actually I got that backwards. Let me try this again once I open the third one. If I say just git config, I'm using this local one. If I say git config -- global, I'm doing this user specific one. Why is the user specific one called global? I don't know, because Linus said so. And then if I say -- system, I'm using this config file, the one that is installed as part of Git. Now I would recommend not doing -- system, because next time you update Git, it will blow away and recreate this file, and you'll lose those system specific settings. Okay, so let's dig into a rebase. Now we did do a merge. Where was it? Are you going to cover rebase? Let's do it. And cherry pick. Git log -- one line -- graph -- decorate -- all. Now I've got this commit and this commit that are kind of out here, and I did this, kind of back and forth type of thing. I would like to instead take this commit and stick it on top of this commit. I would like to change the base commit. I would like to rebase. Okay, so let me say git checkout this commit. Now we're in a detached head state. Yes, we know what that is. That's easy. We just need to create a branch. Git checkout -b rebase branch. Git log -- one line -- graph -- decorate -- all, and we've got this new branch. Now I did stick an old branch over here just in case we do bad things. We can get this solved. But now we want to take this commit and we want to stick it on top of that commit. Git rebase git rebase, and let me put it on top of this commit. Ooh, my index contains uncommitted changes. Git commit -m .git ignore. Okay, now we have one more commit that we'll rebase, and this will actually be helpful in showing us this. We have this commit, and we want to stick them both on top of origin /main. Okay, so let's git rebase origin /main. Now it successfully rebased it. We took this commit and we stuck it on top. We took this commit and we stuck it on top of that. So let's git log, and we can see here's origin main, and here's those two commits right in place. We changed the base commit. Now, if we come back in here into our visualization, we can take a look at this and we can see those new commits. Now, wait a minute. They changed. Here's those two commits. Now, we had those commits before over here. Why do we have a new one? Well, as part of calculating the hash for each commit, it includes both the hash of the contents and also the hash of the parent nodes. Now, in this case, we changed the parent node, and so we get a new git hash. The content of this commit didn't change, but its git hash did because its parent node changed. Why do we do rebase? Great question. Oh, why do we do rebase? Because we want to take commits and put them on top of other commits. So in this case, we kind of flattened out this tree a little bit. This one got put there, and this one got put there. Let's now cherry pick some other commits into place. Now, I don't want this node, but I do want this node. So let me say git cherry pick this file. Now it just picked up that commit and set it in place on my new branch. So there's that file 4. Let's cherry pick this commit. Git cherry pick And we see that in rebase, we talked about where we wanted to move the commits on a branch we were currently on. Where cherry pick, we're picking a commit and setting it onto our current branch. Those are a little bit different, but the third time through, it'll look great. So we've now straightened our tree. That's why we might want to rebase and cherry pick, because we can kind of get a feel for how we can re-alter the commits and tell a more compelling story. Isn't it risky since we are rewriting the Git history? Yes. We're rewriting the Git history. So if I've published commits, if I've done a Git push previously, then, well, all bets are off. And you'll probably merge these things back in. So you'll probably want to rebase and cherry pick before you push. Now let's do one more type of rebase, because I want to say, put some of these commits together. I'm going to say git rebase -I for interactive origin/main. Now, previously, I was trying to move my commits into place, but now I'm going to do an interactive rebase, which will allow me to change commits. Now, in all the Git log history, time moves up. So the most recent commit is at the top. And unfortunately, in this case, the most recent commit is at the bottom, right here. But now I have some commands. I can pick, reword, edit, squash, fix up. So I can reorder these commits. Let me take the git ignore commit and put it at the end. Now, I also want to squash these commits together. So I want to mash it into the previous commit. So let me squash this one and squash this one. And now I've been able to take this one, and then I'll squash these two into it. And then I'll take this one and put it on top. Save, close, and now it's going to go do that rebase. A straighter tree. Well, kind of. It wants to create a commit message. File 7 and file 4 and file 5. I now have a new commit message, and now it will go do that thing. Let's take a look at the graph. And now we have that one commit and then .gitignore over the top. Interactive rebase is really cool in being able to squash those commits together and tell the story in a much more elegant way. Why was I allowed to switch branches when there was an uncommitted file? Because I hadn't committed the file in either the source or the destination branch, so there was no conflict. Good question. Maybe because if we need content of some commit into our branch, isn't it risky? Oh, when to go for a merge and when to go for a rebase? Good question. We did one of each. Now, if we want to tell the story that these commits diverged and then came back together, then we can do a merge. If we want to just stick our stuff on top, we can do a rebase. Now, a lot of people will just merge, and that is totally fine. But I like to rebase my commits over the top, squash them together so that I can better tell the story, better communicate with my team about what that feature is. Now, I used to have 3 different commits that tried to tell the story, but they're all part of one feature. So I just squashed them all together. Now I'm able to tell that story in a more elegant way. That was a lot of fun. We got to look at all of the files inside the .git folder, and we got to see all of the uses of each of the files. Let me paste the repository here again, Git Explorer, and I would invite you to take a look at the repositories that you have. The only way you can break the .git folder is to go change the files. But outside that, everything works out just fine. Thanks for coming, everybody. Now, what's really cool, I'm about to do a talk about doing JavaScript testing. And so jump over to that session and let's dive in. We're going to do another no slides talk about JavaScript testing. See you there. Oh, my Twitter handle at Rob_Rich. Glad you caught me before I flipped over. See you in JavaScript testing in Node, the browser, and CI.